In this video, we are going to learn on how to solve simultaneous equations using matrix. Now, before we begin, we have 2x plus y equals to 4, and we have 3x plus 4y equals to 1. So the first step is to form matrix equations. How do we do it? So we extract the matrix. So we have 2, 1, we have 3, 4, then we have x, y equals to 4, 1. Now in this, this is the linear simultaneous equations, and then now we have the matrix. The first part of the matrix, we call it the coefficients matrix, and then x and y, we these are the variables matrix, and then for 1, this is the constant matrix. Now step 2, we find the determinant of the coefficient matrix. How do we find the determinant? Okay, to find the determinant, we have the coefficients matrix. So we have 2, 3, 1, 4. To find the determinant, we have the leading diagonal, that is 2, 4. So to get the determinant, we multiply 2 times 4, then minus 3 times 1. And of course, this one will be 8 minus 3, which will be 5. So the determinant of this matrix is 5. Step 3, we find the inverse matrix of the coefficients matrix. How do we find the inverse? Now, to find the inverse, first we know that now if we have a matrix A, B, C, D, the matrix is given by 1 over A, D minus C, B in brackets, D minus B minus C, A in brackets. How do we get this? What we do, the leading diagonal, that is 2, 4, we exchange the values, and then the other diagonal, we change the signs. In case for this question, we have a positive 3, so it becomes negative 3, and then 1 will be negative 1, because of course they are positive. Therefore our determinant is 5. So we have 1 over 5, then we have 2, and we have 4, the leading diagonal. So we exchange the values. So we'll have 4, and then we'll have 2, and then 3, because it is positive, we have negative, then 1, because it is positive, we'll have negative. So this is the inverse, which is denoted by A, negative 1 equals to, you can open it, 4 over 5, and negative 1 over 5, then negative 3 over 5, and then 2 over 5. This is the inverse of the matrix. Okay, now after getting the inverse, step number 4. In step 4, what we do, we multiply the matrix, the coefficients of matrix, by pre-multiplying. What do we mean? We pre-multiply this inverse we multiply on the both sides of this matrix. This is how we go about it. So the inverse we have 4, 5, and negative 3 over 5, negative 1 over 5, and then 2 over 5. This is the inverse. So we multiply with the original matrix. Therefore, we go 2, 3, 1, 4, x, y equals to. So the inverse we pre-multiply on the both sides. So we have 4 over 5, negative 3 over 5, negative 1 over 5, then 2 over 5, and then we have 4, 1. Now, the inverse and the matrix, if we multiply the two of them, that's the rows and the column, we'll get what we call the identity matrix. And of course, the identity is given by 1, 0, 0, 1. This is the identity matrix. So if you multiply the inverse multiplied by the matrix, you will get the identity matrix. And then we have x, y. This one is equal to, we multiply the rows and the column. If we multiply, we'll get 4 over 5 multiplied by 4 plus this and this. We have negative 1 over 5 multiplied by 1. Then the row and the column. So we'll have negative 3 over 5 multiplied by 4 plus 2 over 5 multiplied by 1. This side, if we multiply, we'll have x, y. Then we have 16 over 5 minus 1 over 5. Then negative 12 over 5 plus 2 over 5. Okay, then we proceed. So x, y, if we work out, we will get 15 over 5, and then the other one will be negative 12 over 5 plus 2 over 5. Of course, we have negative 10 over 5. Therefore, x, y equals to, if we divide, we'll get 15 divided by 5. This one is 3, and then we'll have negative 2. Okay, so x, y is equal to 3 and negative 2. Now, this part, we don't leave the answer in the form of xy equals to negative 3 equals to 3 and negative 2. So the answer should be written in this form. So we come and say x equals to, the value of x equals to 3 and the value of y equals to negative 2. So this is the way we leave the answer. Thank you for watching.